Hey everybody, welcome to this Unreal Engine webinar on post-processing. We'll be getting started in about 8 minutes, but if you're just joining the channel, please be sure to maximize your web page or make it full screen so that the browser will refresh and you can see the webinar in all its glory in full size. Hey everyone, welcome to this webinar for Unreal Engine post-processing and cinematics. We're going to get started in about 5 minutes. For those of you who have just joined, please be sure to maximize your web page or make it full screen so that you can see the webinar in full size. Otherwise, it will not update on its own. Hey everyone, it's Matthew again. Welcome to the webinar today for Unreal Engine and post-processing. We're going to get started in 2 minutes, so be sure your web screen, your web page is fully maximized. You can hit F11 to go full screen, but if you do that, you'll lose the chat. You'll have to hit F11 again if you want to see your chat again, but just make sure the screen is big so you can see the webinar in full size. And we'll talk to you soon. Welcome to this Unreal Engine webinar on achieving cinematic quality with post-process effects. My name is Matthew Doyle, and I'll be your host today. I'm a former game developer, and I've worked in many different areas of the development pipeline. The webinar will take up about half an hour or so today as I walk you through the basic use of the various post-processing tools to help you achieve higher quality cinematics. We'll also be taking a look at using post-process materials towards the end of the webinar for achieving specific stylized looks. Before we get started, let's take a quick look at the final output in a sequencer cinematic that I put together. Okay, so that is our final target for today. I apologize if it's not running at a smooth 30 FPS. Obviously, over a webinar like this, there's going to be some issues, but I think you get the point. So you saw we had several effects layered on top of each other in this sequence. We had some vignetting and lens flares and light bloom. We also have some color grading, exposure controls going on here, and some tone mapping. And we're going to look at all of those today, including ray tracing. For those of you unfamiliar with the post-process workflow, post-processing is the last step of rendering a single frame inside of Unreal. Kind of like in the film industry where the post-process workflow is the last part of creating a film. Post-process effects are generally in screen space, meaning that they are affected by and affect everything that you currently see on the screen. And they're used to add visual effects. Effects such as light blooms and lens flares, but also things like color grading and tone mapping. Post-processing is tied to either a camera or a volume, and in some cases it's best to work with a camera. Now when working with a post-process volume, you can add multiple volumes to your scene, and each volume can have its own settings. And volumes can overlap one another. You can set the priorities of the volumes so that depending on which volume you are inside, the volume with the highest priority will take precedence. Volumes can also be bound or unbound. A bound volume requires the viewer to walk into it in order for the post-process effects to occur, while an unbound volume allows those post-process effects to occur at all times, whether the viewer is inside the volume or not. These are the topics that we'll be discussing today in the webinar. We're going to start out by looking at tone mapping, which is like basically selecting a film stock for our project. After that, we'll look at the color correction controls. Then we'll look at lens effects, rendering features, which includes ray tracing options, and finally we'll talk about adding post-process materials to your scene, which allow you to add full-frame custom effects such as outlining or other stylized effects. To begin, I'm going to select the post-process volume that I'm currently using in the scene, and I'm going to disable it. This brings our scene to a clean state where we have no post-process volume effects being applied. We'll also want to disable all effects in our project settings under Engine and then Rendering, and in here we want to scroll down to Default Settings. From here we'll disable Bloom, Ambient Occlusion, Auto Exposure, and Motion Blur. Now to work with a post-process volume, we'll find those under Visual Effects or Volumes. You can also simply search for Post and then drag it into the scene. In game mode, with it selected, the post-process volume will look like an orange box. On the Details panel, we want to make sure that Infinite Extent or Unbound is checked. This ensures that the post-process volume settings will take effect whether we're inside the volume or not. We're now ready to begin adjusting the effects, so let's scroll up to the top and start from there. So the first options we have available to us are lens effects. Inside of here you can see that we have mobile depth of field for mobile devices, bloom, exposure controls, chromatic aberration, dirt mask, camera controls, lens flares, image effects, and finally depth of field. We're not going to be using depth of field today, but instead it's best to control your depth of field with your cameras. So if I go to my cinematic and then pick a shot, you can see that I'm controlling my camera's manual focus distance here inside of the sequence. I'm also controlling the current aperture width as well as the current focal length. This gives me the most control over my depth of field, and it allows me to animate it. Let's reselect our post-process volume now. And we'll start with bloom. To see the bloom, we need to find a nice bright object in our scene, such as the sun here. Bloom allows us two options for controlling the bloom: standard or convolution. The standard bloom is the basic bloom inside of Unreal, and it's best used for real-time situations, such as during gameplay. You can control the brightness of the bloom using intensity, and the threshold determines which pixels will emit bloom. The higher the threshold, the brighter the pixels need to be before they emit bloom. The second option is convolution. Convolution allows for a more realistic bloom and can make use of custom convolution kernels or textures. Keep in mind that convolution is designed to run in cinematics and not real-time because it is more expensive to use. You can see, however, that with convolution enabled, we get a more star-like pattern on our bloom. And this is because it's making use of a kernel or texture map. We can also open the advanced options here. These options will allow us to control either the standard bloom or the convolution bloom. So let's go ahead and enable all of these convolution bloom options here. So first of all, we can control the scale of our convolution bloom, so we can make it much smaller. Using the convolution boost min, max, and multiplier, we can control the intensity of our convolution bloom. Next up are the exposure settings. If we open those up, we can see we have several options here, and the first one is our metering mode. By default, Unreal uses an auto exposure histogram. This allows for eye adaptation. As we look to a darker area in the room, our eyes will automatically adjust, making that area brighter. Remember, however, that we've disabled those settings in our project settings. So in order to see the effect, we need to go back to Engine, Rendering, Default Settings, and re-enable auto exposure. Now, if we want to lock the auto exposure to a specific exposure value, we can enable min and max brightness and set them both to 1. Now as we look around the room, our exposure will not change. Unreal comes with a histogram visualization tool. We'll find it if we go to the Show menu and then choose Visualize and pick HDR Eye Adaptation. This gives us a heat map of our exposure values in the scene, and it also gives us a histogram along the bottom. The blue values represent the darker parts of the scene. Green values represent the midtones. Red values represent the highlights. We can see our current exposure value with the white line, and the blue line represents the exposure target. Now, to see the effect of our current exposure moving to represent our eye adaptation, we'll of course have to reset our min and max brightness. And now you can see the current exposure value moving towards the target. We can use speed up and speed down to control how long it takes to move to the target, whether it's going down or up. But let's go ahead and set our exposure back to 1 and 1, locking it in place. And we can turn our histogram back off. And let's look at manual exposure control. Setting our exposure to manual, you'll notice the scene gets very dark. And this is because we have to control our camera settings, and that includes shutter speed, ISO, and f-stop, as well as the lights properties. So for instance, if we wanted to go with a typical sunny day using the sunny 16 rule, we need to set our shutter speed to 100, our ISO to 100, and our f-stop to 15. However, the scene still looks too dark. That's because our lights now have to be tweaked. So if we select our sunlight, we can go up to the top of the details panel and change the intensity to something more physically accurate. In the case of sunlight, that should be about 82,000 lux on a sunny day. You can see that when we do that, the sunlight comes back in. Obviously, however, we're going to need to rebake our light maps to see the results of any indirect lighting to continue from here. Rather than do that, however, we're going to stick to Unreal's automatic histogram. So we'll go ahead and set our sunlight right back to 10 lux. And we'll go back to our post-process volume. And under exposure, we'll set our metering mode back to auto exposure histogram. Just keep in mind that if you have specific camera settings from real-world photography that you'd like to match inside of Unreal, you can certainly do that using the exposure and camera settings of your post-process volume. These same options are available to you inside of the camera as well, inside of Unreal if you're using the camera's post-process settings. After exposure, our next option is chromatic aberration. Chromatic aberration creates a red, green, and blue separation, and it's used to simulate a distorted or old lens. If I adjust the intensity, you'll see the difference it makes. You can see clearly on the fringes how the RGB values have been separated. Now this can work to great artistic effect, but it can also help to soften up your image, making it look less computer generated if you use very small values here. The start offset controls how far away from the center that the effect begins to occur. Next up we have a dirt mask. The dirt mask is an option that allows us to use a texture to simulate a dirty camera lens. So for that, we'll first need to look at a bloomed object here, and then we can enable the dirt mask texture. Using the drop down, I'm going to search for dirt. I have a lens dirt texture here that I'm going to apply, and then I'll want to adjust the dirt mask intensity. The dirt mask may not be visible at first, and that's because it generally works best when you have high bloom and lens flares. So that brings us to our next option, which is lens flares. To control lens flares, we have intensity, as well as bokeh size, threshold, and bokeh shape. We can also tint the lens flare's overall appearance, or we can open up the tints rollout here and control the tinting of each individual bokeh. Obviously, with the intensity, we can control how bright our lens flare is. The bokeh size allows us to control how large the bokehs are. Much like bloom, threshold allows us to control how bright pixels have to be before they will emit lens flares. And for bokeh shape, we can choose different bokehs. You'll notice now that as I look towards the sunlight and I hit the lens flares just right, we can see some of the noise of the lens dirt. Once we've adjusted our lens dirt and lens flares, this brings us to our last option, and we'll find that under Image Effects, and that's going to be vignetting and grain. Vignetting is a great artistic effect that allows us to focus the viewer towards the center of the screen. We can adjust the vignetting intensity by using the slider here. Keep in mind that if you want more intense vignetting, you can go even higher by simply typing in a value. Grain, jitter, and intensity allows us to add film grain. It may be very hard to see on the webinar, but now that I've added some film grain, we get more of an old-fashioned film kind of look. Once we've got all of our lens effects applied, this brings us to our color correction workflow. The color correction workflow inside of Unreal is a combination of tone mapping as well as color correction. When you're doing color correction, You should follow this procedure in order to make sure you get the best results. The first thing you'll want to do is turn off auto exposure in your project settings. After this, you need to set your white balance using the temperature of the post-process volume. From here, you're ready to work with the tone mapper, and this is done on a global or project basis. So once you've set your tone, you're ready to move on to your color correction workflow, and the color correction tools are meant to be used on a per shot basis. You'll see in the color correction workflow that the first option you'll have is global settings, and generally you want to adjust your global settings first, and then if you need to, go back and adjust shadows, midtones, and highlights separately. The Filmic Tone Mapper inside of Unreal uses the Academy Color Encoding System, or ACES, which is industry standard for film and TV. It's the closest approximation to the color gamut available to the human eye. And what it does is it maps HDR renders which come out of Unreal to low dynamic range displays. You should use the Filmic Tone Mapper for your project-wide look. So once you've set it for the entire project, you shouldn't have to change it again. This is like setting a film stock for a movie. The Tone Mapper in Unreal is essentially an S-curve, which you can see on the screen here. And the S-curve has several parts that you can adjust inside of the post-process volume. First of all, you'll find the slope. This controls the overall shape of the S-curve. Next, at the bottom of the S-curve, we have the toe, which controls the darks. And at the top of the S-curve, we have the shoulder, which controls the brights. Finally, we have black clip and white clip. These are used to control the maximum darkness and the maximum brightness, respectively. The best way to work with the Filmic Tone Mapper is to enable the slope, toe, and shoulder. Black clip and white clip are usually fine to leave as is. However, if you want to adjust them, the options are there. Controlling the slope controls the overall contrast of our image. I'll set mine to about a value of 0.6. To work with the toe, you generally want to find a dark area in your scene. And while looking at a darker area, you can use the toe to help lighten it up some. Obviously, the more you do this, the more washed out it's going to appear, so avoid using large changes here and instead work with small values. Likewise, to work with the shoulder, it's best to find a bright spot in your scene and then adjust the shoulder from there. Once our project's filmic look has been selected, we're ready to move on to color grading. The first option under color grading is our white balance, and we have access to temperature as well as tinting. Tinting allows us to apply a global tint to the entire scene. Generally, I prefer not to use this value. For temperature, the best workflow is to find a very white object in your scene, such as this chair here, and then adjust the temperature so that it looks white. Alternatively, if you're going for an artistic effect, such as a warmer or cooler scene, you can tweak the temperature so that you get that effect. From here, we have global, shadows, midtones, and highlights. The best workflow is to stick with global and make all of your changes here. If after you've made all your changes under global, you still feel like you need to tweak specific parts of your color, such as shadows or midtones, then you'd move down to these options and you'd tweak from there. If we open up global, we'll see that we have saturation, contrast, gamma, gain, and offset, and you're going to find all of these same options under shadows, midtones, and highlights. The global options control the overall look of your scene, while under shadows, the same options will control just the shadows. If we open up saturation, we can see we have a color wheel, as well as an intensity slider. So I can control the saturation of my scene. I can make it fully black and white. Let's go ahead and go with about 0.77. I can control the intensity of individual color channels using these sliders under RGB. Now you'll notice as I control the intensity slider here, it's controlling all three channels, red, green, and blue, but using the luminance slider, I'm just controlling the intensity of the overall effect without adjusting these values. I also have the option to work with hue, saturation, and value instead. Now, if we open up contrast, the difference here is that the color wheel works in a complementary fashion. So, for instance, if I wanted my highlights to be more orange, I can drag the color wheel in that direction. But you'll notice now that my shadows are bluish because they're on the opposite side of the color wheel. After this, we have gamma, which controls our midtones. Adjusting the color wheel under gamma, you can see clearly that this has the largest effect on the overall color tone of your scene. Gain controls our highlights, and then offset for our shadows. So for instance, if we want our highlights to be brighter, we can simply use the intensity slider here to bring those highlights up. We can do the same thing for our shadows and bring those down. And again, once you've set all of these to your liking, if you need to continue to tweak, say, the shadows or the midtones, you would simply open up these options and then have all of the same controls here where they only affect the shadows. Obviously, color correction is a very subjective process. Just keep in mind that when you're working with color correction tools, the objective is not to fix lighting or material issues. If you do have lighting issues or material related issues, it's best to fix those using the lighting tools and the materials tools. Color correction can solve some minor problems, but generally it's used to create an artistic effect. So this brings us to the next part of our post-process volume, and that's going to be rendering features. Under rendering features, we have the ability to use post-process materials, and we'll talk about that a little bit later. After this, we can apply an ambient cube map, which can be used to tweak the overall ambient lighting. To do that, we'll simply go to our cube map texture, and we'll pick a cube map, and then we'll adjust the intensity. Let's go with something a little more subdued. After this, we have ambient occlusion. Ambient occlusion simulates how light bounces around a scene and has a tendency to miss corners and cracks and so forth. In order to see the ambient occlusion, we can visualize it. If we go to our view mode and choose buffer visualizations, we can select ambient occlusion. Now I can control the intensity of my ambient occlusion, as well as the radius. The radius determines how soft or sharp the ambient occlusion appears. Now Unreal also has options for using ray traced ambient occlusion. To use it, we simply need to enable it. From here we can control the quality of the ray traced ambient occlusion by increasing the samples per pixel. While using ray traced ambient occlusion, the intensity and radius settings will still apply. After ambient occlusion, we have options for controlling the global illumination contribution in the scene, as well as using ray traced global illumination. To control the intensity of our global illumination, we simply need to put a check here where it says indirect lighting intensity, and now I can boost or lower the amount of indirect lighting contribution. And again, just like ray traced ambient occlusion, we can enable ray traced global illumination. To control the quality of our global illumination, we can adjust the maximum bounces as well as samples per pixel. Actually, to better see some of these effects, let's go ahead and turn off the film grain and jittering effect. After ray traced global illumination, we're going to skip down to reflections here. We have three options for reflections. Let's open up all three of these. First of all, we have reflections, and this allows us to specify the type of reflection we're going to be using. Then we have screen space reflections, and finally, ray tracing reflections. This allows us to control the ray traced reflections, while screen space reflections allows us to control those. Now looking at the mirror, if I change my reflection type to screen space, you can see the effect that it has here. Screen space reflections will only reflect things that are currently in the viewport. That's why all you're really seeing is the character reflected in the viewport here. Screen space reflections will work great in some situations, but not so great in others. So we're going to go back to ray traced reflections, and clearly you can see how much more of a difference they make. To control our reflections, we'll want to adjust maximum roughness and maximum bounces. By default, we're only getting one bounce, so we're not capturing other reflections on any other reflective objects inside of this mirror. If we wanted to see more reflective objects, we'd need to increase the number of bounces here, so I'll go up to 3. Now you can see the floor here, which is slightly reflective. You can see its reflection in the mirror. Lowering the maximum roughness can help improve performance, but obviously the lower the value, the less ray trace reflection you'll see in a rough surface. So by bringing this value up higher, we can see that rougher surface will begin to have ray traced reflections. Next up we have translucency. For this I'm going to move over here to these glasses. Now right now these glasses are using standard translucency inside of Unreal, and we can change the type of translucency used here in our post-process volume. We'll open up translucency and ray trace translucency, and we'll change the type from raster to ray tracing, and we can see how they change, but you'll notice that everything is currently black, and that's because we don't have enough refraction rays right now. So to increase that, we're going to enable max refraction rays, and I'm going to boost this up to a value of 6. By doing that, we can clearly see now we're getting a much better refractive translucency here. Maximum roughness works the same way as it does with ray tracing reflections. Lower values will help to improve the performance. But of course, in doing so, you're also reducing the maximum roughness value of a material that will make use of ray traced translucency. Unreal's ray tracing solution is considered a hybrid solution, so each of these can be turned on or off individually. You'll also notice that with all of them on right now, the frame rate is not that great, so we need to decide which effects have the most impact on our scene, and then disable the others. I'm going to stick with using ray traced reflections and translucency, but I'm going to go ahead and turn off ray traced ambient occlusion as well as ray traced global illumination. And simply by disabling these two options, we can see that my frame rate is at a much better level, and we still have ray traced translucency, ray traced reflections, and in this case we're also using ray traced shadows on our lights. Now we can animate all of these values in our post-process volume in a cinematic. I have a cinematic here already. In order to animate the post-process volume, we'll need to make sure that we have it selected. From here, inside of our cinematic and sequencer, we can right-click, add the actor to sequencer. Once our post-process volume has been added, we can add individual tracks either from the details panel and click on the add keyframe button, or we can simply click the add track button, go down to settings, and pick any of these options available to us in the post-process volume. So for instance, I could select color grading global, go over to my gamma and select it. Let's scrub the timeline ahead a little. And then from here, I can open up my gamma settings and I can make some adjustments. Let's go ahead and add keyframes for my color values. We'll scrub ahead a little. Let's make sure that we're using this current shot, so we'll lock it to the viewport. And now I can make tweaks to my color values. The last thing I'd like to show you today is the post-process materials workflow. Post-process materials allow us to create all sorts of full-screen custom effects using materials. For instance, we have currently this toon shader effect applied across the entire scene. We can replace it with another one here that gives us more of a blueprint effect. Today we're going to look at how to easily create this black and white shader so we have a nice desaturated look, but we also have some objects in the scene that are retaining their color information. This works great to give you a Schindler's List style effect where you're telling a story in black and white, but you want certain objects in your story to be highlighted so the viewer pays attention to them. Before we add a post-process material, let's take a quick look at the G buffer of our video card. And we can look at the G buffer by going up to our View options and then go to Buffer Visualization and choose Overview. This allows us to see every render target of our G buffer. The G buffer is a space in memory of our video card where all of the different material inputs are being rendered to using render targets. So for instance, we have our base color material input here on the top left, and this shows just the base color information of our materials. After that, we have specular, subsurface color. Here we have the world normals. You can also see we have metallic, so every object that is marked as metallic in a material is being rendered here to the metallic G buffer. Then we have roughness, so we have our grayscale of all the roughness of all of our materials being rendered to that G buffer. And so Unreal uses a deferred renderer, and what it does is it takes all the different material inputs from all the objects in the scene and then turns them into these render targets, which are stored in memory in the G buffer on the video card. And eventually the video card will take all of these different render targets and then combine them together to create the final image. And so in the material editor, we have access to all of these different G buffers. We can use these to create all sorts of different special effects, and we're going to use some of them today to create our post-process material. So let's go ahead and turn this off. We'll go back to lit mode. But before we do, if you ever want to see a specific G buffer, just go down to Buffer Visualization, and rather than pick Overview, all of these different G buffer render targets are available here. So we've got our base color, We have custom depth, custom stencil, and so forth and so on. So you can always just pick one of these. So for instance, I could choose roughness here, and now I'm using the roughness G buffer as my final output in the viewport. So let's go back to lit mode. If we select our post-process volume and then go down to rendering features, under this, the first entry here is post-process materials. Under post-process materials, we have an array, and we can store a collection of different post-process materials here as elements. To add an element, we'll simply click this Add Elements button here, and we're going to use the drop-down of our first element and change it to Asset Reference. Now we need to plug a material in here that will be used as our post-process material. To do that, we need to create a new material, so we'll simply right-click and choose Material, and let's call this ppm underscore black white highlight. Now we can open this material and begin to edit it to create the effect we want. In order for a material to work as a post-process material, the first thing we need to do is to change the material domain from surface to post-process. After that, we can go ahead and begin to add the nodes that we need here. So for this particular post-process material, we're going to create the black and white or desaturated look where we can highlight specific objects in the scene. In order to do that, the first thing we need is what's called a scene texture. So if we right-click and search for that, scene texture, this is going to give us access to all of the different G buffers that we have available. So if you recall, when we looked at the buffer visualization overview and we saw all of the different G buffers for things like metallic, opacity, world normals, and so forth, this texture node here, this material node, scene texture, is going to give us access to all of those G buffers. And so what we want to do first of all is we're going to change the scene texture ID to post-process input 0. So essentially this is going to give us access to how the screen looks once all of the G buffers have been combined together. So this is the final output. And the first thing we're going to do is we're going to use the color output here to desaturate it. From here, we simply need to connect our desaturation to the emissive color, and then we'll save this. Now, in order for our material to take effect, we simply need to drag it onto the swatch of our first element. You can see the swatch is outlined in green. And as you can see, we have a desaturated or black and white image now. Now to complete this effect, we want to add a highlighted item, something that we can tell a story with. So perhaps in this case, we want to highlight the oranges on the table here. And in order to do that, we're going to use the custom stencil buffer. Now in order to make use of the custom stencil buffer, we're going to have to go to our project settings to enable it. We'll find it under Engine and then Rendering. And in here we want to scroll down to Post-Processing. Under Post-Processing, you'll see Custom Depth Stencil Pass. You need to make sure that this is set to Enabled with Stencil. After that, we need to specify which item in the scene that we want to have the highlight. So I'm going to select this orange here. In fact, I'll go ahead and select all of the oranges on the plate, holding down the Control key to do that. And then if I go to the Details panel and search for Custom, we can see that we have under Rendering, Render Custom Depth Pass. So we're going to enable that with the checkbox. Then we need to specify a custom depth stencil value. I'm going to put a value of 1 here. And now if I go to the View options in the viewport and choose Buffer Visualization, I can choose Custom Stencil, and this will show me that the oranges now have a custom stencil G buffer, and you can see the value there of 001. This means we can now use this custom stencil buffer inside of our material. So in order for our oranges to show up, we're going to use another scene texture. So we can simply copy this one, and then we'll go to our scene texture ID, and we're going to use the custom stencil buffer. Now what we want to do is use this as a mask to apply color on just the objects that have custom stencil buffers selected, while still maintaining everything else in black and white. So to do that, we're going to use a linear interpolate node. I'm going to hold L on the keyboard to create that. And then we'll take our desaturated version of the scene and plug that into the A input. And we'll take the custom stencil buffer and plug that into the alpha channel. And then we'll take the post-process input 0 version of the scene, and we'll plug that into the B input of our lerp. And then if we plug that into our result node and then save it. Now if we look really close at the oranges, you may notice they do appear a little bit oranger than usual, and there's kind of an outline on the side here, kind of a ghosted image. It's probably quite hard to see, but there is kind of a ghosted outline here. So this is because the way we're rendering, or rather I should say when we're rendering the effect. So let's open up our post-process material and look at how we can change that. So with our result node selected, if we go to our details panel and scroll down to the post-process material rollout here, you can see the blendable location. By default, this is set to after tone mapping, which means it's literally being done after the very last step of rendering the frame, because tone mapping is the last step where we translate our HDR image in Unreal to low dynamic range displays. We can change this using the drop down to several different locations. So we can have it be before tone mapping, or even before translucency, and a few other options here. So if you've got any depth of field with camera settings, you're probably going to want to use before translucency. But for now, we're just going to use before tone mapping. Now, if we hit save, you should see the oranges will change. They're not so bright anymore, and that little bit of a ghosted edge should be now gone. One final thing to consider when changing the blendable location in the post-process material is the effect that its location has on other post-process effects, such as this lens flare. Because I'm doing the post-process material before tone mapping, it's occurring before the lens flare is being added to the scene here, and so our lens flare is in full color. So if we wanted to bring this lens flare back so that it is also desaturated, we would need to change our blendable location again. So let's set it back to after tone mapping. And now we can see that the lens flare is being fully affected by our post-process material now. I hope this webinar on post-processing in Unreal Engine has been informative. The end results of the post-process workflow are highly subjective, but the concepts and techniques that we've looked at today should help you achieve the look you're going for. So thank you all for attending, and for those of you that would like to stick around a few minutes more, we'll now open things up to Q&A. Okay, everybody. So we're going to be here for a little while, so feel free to stick around, and I'll be happy to answer any questions that you guys have. If you can't stay around, thank you so much for coming and being a part of my webinar today on Unreal Engine and post-processing. We'll try to answer as many questions as we can. Bear in mind that there are a lot of things to know about Unreal. Not one guy does not know everything, so you'll just have to we're going to be here bear with us if we don't know the answers, but we'll do the best we can. So again, thanks. Stick around. Daryl, are you here with me?
I am, yeah, absolutely. Happy
Okay,
to
great.
happy to help out where needed.
So we have another gentleman on our webinar with us today, Daryl, and Daryl is a very knowledgeable guy. So if I don't know it, he probably knows it.
We can give it a good honest try. So yes, so there was a question about VR applications. Yeah, there's a couple things that the post-processing effects that are a little costly. If you hit Control Shift comma, you can get a good sense of where things are sort of taking time when you're kind of trying to scope stuff out. Something like the convolution bloom model adds about 5 milliseconds for example. So that's one of the costlier effects in post-processing. A lot of them are almost free, like things like the color correction stuff and things like that are basically free, but some of the depth of field effects come with a slight cost, and some of the blooming and lens flare effects can can kind of all add up. So it is a place to look to tune for performance.
Yep.
And there was also a fair number of questions that kind of came through about ray tracing and ray tracing in general. So yes, it works off of, currently it works off of NVIDIA's RTX cards primarily. You can use a legacy card, a 1080 based card, or that kind of 10 series cards, and it's done at sort of with a driver. You have to have the most current drivers, so it's not using turning cores in, so it's not going to be accelerated in hardware. So it's an order of magnitude slower. So if you wanted to get a taste of it, of like what's it look like, you could certainly use those legacy cards, but to really get a feel for what it's like to work with the ray tracing functionality, you need to jump up to an RTX card. And the improvements that are happening every release are pretty drastic on the ray tracing front from a performance and a visual fidelity point of view. So preview 3 or preview, I think preview 4 just came out today. Lots of nice improvements to the ray tracing, both in terms of functionality
Yeah.
and performance in
Yeah.
424.
So I want to jump on some of these G-buffer questions real quick too. So we've got questions about how to do outlines like the blueprint effect. So that is probably your best bet, is going to be using custom depth. You would create a mask of your characters or whatever, and then you use that mask to create the outlines. There's a great class on the Unreal Learning Academy on, I think it's called Stylized Effects with Post Processing. Check that class out. He goes into considerable detail on how to use the custom depth pass to do like cartoony stylized outline stuff. And as for the process of creating a post-process material, yeah, it's pretty much the same across the board, but it depends on the effect you're trying to create. They can get a lot more complex than what I showed you today. Like what I showed you today was a very simple, quick material. But like for doing cartoony stuff with outlines and all sorts of other effects, you can get up to 100 nodes pretty quick in the material editor.
So another question that was pretty asked often is, are we going to repeat the webinar? Yes, you'll get a link sent out that will have a click through to the actual YouTube version that sits on our website and stuff like that. So you will be able to go back and watch it later. And it looks like there was a GI question. So real-time GI it's still, this is an area where we're really stretching what the hardware can currently do, as well as the software. Like the software algorithmically is going to improve moving forward, as well as the hardware. So GI is still really tough to do on exterior scenes. You can do some stuff with it that starts to kind of work. In 424 there are a couple of things with GI that are worth looking at. There's a new final gather method that does basically doubles the frame rate, but doesn't have the same light propagation values, or the same ability for light to transport itself and bleed color as much, and to add areas to the darkness as much, but it is much faster. There's also screen-based GI that's in screen space effect GI that was added to 424. So that is not dependent upon RTX hardware. It actually runs on like PlayStation or mobile, other platforms. It's a screen effect, so the object, it has all the limitations of other screen-based effects, but it's basically from a performance perspective, very low cost.
So there was a question about how to render out these different G-buffer or render targets. You can use a sequencer. You can see on my screen here, hopefully, if you open up this icon at the top that looks like a take. Gosh, I can't remember what they call it at the board. And this will allow you to render out your sequence, and you can change the output to render passes. And then under composition graph options, you can choose what render passes that you'd like to render out. So those render targets we were looking at can all be rendered from here.
Yeah, and if you wanted to add a more elaborate workflow to get outputs, you can also, there's a plugin that you need to enable called Composure. Or if you just go to our docs and look up Composure, that's a compositing system that allows you to isolate objects using a layer system and kind of do A over B simple compositing inside of the engine and things like that. Simple green screen work can also be done with it. And it has a section for specifying out and defining AOVs for a given layer that you've used using that Composure layering system. So that's another area to kind of dig into if you want.
Yeah.
Uh,
There's a question on post-process materials. Is there a way to create a material that changes depending on the camera position? Yes. So that would be, I can't go over the exact steps. It's pretty complicated, but yes, you can create a material that changes based on where the camera is looking.
There was another question about global illumination. So the way the global illumination works in the post-process volume, or using console variables, if you didn't want to manage it with the post-process volume, you can set the number of bounces as well as the number of samples. So the higher the bounce goes, as well as the higher the samples go, progressively slower and slower frame rates. So GI, you're not going to get real time, right? Like if you're trying to do a GI based scene and you want to render out an animated movie like Matt showed at the beginning, or you want to use it to generate a still, totally workable. If you're trying to do something that's real time, my suggestion is a hybrid approach, sort of similar to what Matt showed, where you still use a light mass or a baking process to get the indirect lighting model baked into textures, and then you have some live objects inside of there that are using more of a direct illumination model with movable objects.
Yeah, did you cover the question about, there was a question about ray tracing recommended number of bounces for cinematic quality?
As high as you go until your video driver
That's
fails.
that's what I was
Like,
gonna say. Yeah, I was
I
gonna
mean,
say as many as you can get while maintaining good performance.
yeah,
Yeah,
it,
those
it'll it'll
questions are
it'll
hard.
eventually it'll
Different
eventually
hardware.
crash. Like
Yeah.
it's getting better every release. The denoisers are getting better every release. We're continuing to add, like there's a new hybrid reflection mode that we just added in 4.2.4, which is really awesome. In 4.2.3, we added the ability to have a second bounce, go out and use the reflection probes or the legacy reflection models. So, we're continuing to try to improve and give you more tools that allow you to get higher fidelity while still maintaining performance. So more kind of gaming trick workflows and things like that to try to match the performance versus the visual fidelity that you're trying to maintain.
Yeah, someone was asking about how to specify which stencil you're using in the material effect. There's some great tutorials by Tom Lumen there. I posted a link in the chat on how to work with the stencil buffer. So it can get pretty complicated, obviously, but go through those tutorials. That's how I learned it. So definitely check that out, and it'll help you.
Yeah, I think he has some cool stuff on there too about like shadows, where you can have a completely
Yeah,
separate set of geometry casting a shadow versus the primary rays,
yeah, he's got
which
outline
is pretty
stuff
cool.
using the stencil buffer, but he's also got, like you said, the shadows. Like the shadows can be a different texture than the texture that's on the wall
Yeah, that's what it
normally.
was.
Like
It was
really
like a
cool. Yeah,
wallpaper.
yeah. Guys, there's a lot of questions coming in. They're coming in pretty fast. So if we miss you, please accept our apologies. We're trying to get to them, but it came in
So
pretty fast for a while there.
yeah, I can talk to you about the AI denoiser. So there's lots of denoisers. If you just go to the console variable, you get that by hitting the tilde and just type denoiser. You'll see that there are some that are ray tracing specific and some that are engine specific, broken down to things like skylight versus reflection. So there's a variety of controls that you have. When ray tracing, the AI denoiser only works when you have a single sample. So as soon as you go to more than one sample, the AI turns off, and you're using an approach of multi-sampling. So often, like one sample is going to look better than maybe three or four samples, but once you get the sample count on like reflection or something like that up to 10, 16, something like that, it's going to look better than the AI, because you're brute forcing it at that point. But it takes a bit before the one sample with AI doesn't look better. Probably
Daryl, do you
probably
know
around
the
6 or
answer
7.
about the lighting types? Do they have to be movable or stationary for ray tracing to work?
Oh, it doesn't matter.
Okay, I didn't think so. Yeah, I just wanted to
Yeah, it
verify it.
doesn't. 'Cause, if you want the lights to, if you are doing a light bake and you want the lights to bounce light around the scene, they need to be in stationary, or like they can't be movable basically, because they're
Yeah.
they're fully dynamic at that point.
And as to the second part of your question, Botzing, I disabled ray traced ambient occlusion and ray traced global illumination to get my frame rate back up. So generally, that's why it's a hybrid ray tracer. You go with the ones that have the biggest effect on your view, on your output, and I felt like the biggest impact was being made by reflections, translucency, and shadows. So I turned the other two off.
Yeah, so the answer to the question about ray tracing agnostic. So what we're doing for the ray tracing is we're just using DXR, right? So when AMD supports that, or when the Kronos group supports it on Linux, then we will obviously support it. We are hardware agnostic. It's just that we're literally using turning cores that are exclusive to they're the first to kind of get it out as an exclusive thing for it's NVIDIA's tech basically. But eventually it's written in a hardware agnostic way.
Does Unbound post process have calling in big maps and environments, and does it affect optimizations? My answer on that would be a no, because post processing is mostly screen space stuff. So it doesn't matter how big your map is. It really, overall shouldn't matter because it's all being done on as the last step of the rendering pass, and it's just all screen space for the most part.
Yeah, it's your resolution of the image that you're rendering matters. So if you're
Yeah,
doing,
yeah.
4K versus, something that's smaller, that you'll feel it. Yeah, alternative ray tracing. Yeah, I'm not. I think that DXRs in Vulkan with the Kronos group is sort of the future, and that's where we're going.
Yeah, and the idea is yes, ray tracing will replace light baking eventually. That's the idea. If you have full on global illumination, full on ray trace shadows, all that stuff, you ultimately won't need to bake light maps. We're not quite there yet, I don't think, but we're that's where we're headed.
Be a long time.
Yeah.
So it will remain a hybrid renderer. It will obviously continue to get better, but to ray trace on a phone, on a Fortnite mobile on an iOS device, it's a ways
Yeah.
away. So it's sort of the hybrid approach is here for the foreseeable future.
Can we use the output of custom mesh passes in post process materials? I'm not sure what that. I'm not sure I even understand the
Like a
question.
shape instead of a volume. I've never tried to shove something into the brush shape or something like that. Maybe. I've actually never looked.
Yeah, that's one neither of us knows. Our brother
Yeah.
knows.
The source code is out there, so
Yeah.
you could rip it apart and make it happen. Let's go with that. Specs on your equipment, Matt. What are you running?
I'm running a 2080 Ti for video card. I've got 64 gigs of RAM. I think I'm on an i7, which I actually just bought a new computer that I'm building, which is an i9. But yeah, right now I'm on an i7, 64 gigs, 2080 Ti,
Nice.
SSDs.
Boom. What you want. So ray tracing in VR. So 424 that's in preview now does support the ability to do ray tracing in multi frame as well as in display. So you can tile it across an array of machines or an array of displays. And certain things are going to be really fast in ray tracing, like ray tracing shadows are really, really fast. Actually, I know that Matt said he turned off ray trace ambient occlusion, but that's actually one of the effects that's pretty low cost. So there are some situations where you could start to implement ray tracing into a VR scenario and still maintain your performance. Yes, it doesn't work with forward rendering. So it does in VR doesn't have to be forward rendering. That's just it's a nice thing that you can do to you go get the second frame for free. But there's situations where people do certain things without forward rendering. So yeah, if it's a simple case and you're doing very specific things, it could work. It's going to be a challenge to get to 90 FPS, but people are doing it for sure. It's very, very selective in where you're choosing to cast those rays.
So it looks like the questions are starting to slow down. If there's any that we missed, feel free to post it again. I'm happy to stick around for another 5 minutes or so. But if not, if we're not going to get any more questions, what do you think, Daryl? You think we're good to go for the
Yeah,
day?
we're kind of wrapping it up here. Thanks again, everybody. Matt,
Yeah,
great job.
thank you all so much for being here for the webinar. Hope it was educational for you guys, and we really appreciate all the questions. It shows that you're definitely interested in what you're learning
I,
about.
I like this question. So you're an Intel and NVIDIA fan. I'm going to say I want a Threadripper 3. I don't know if you guys have seen the specs for
Yeah,
the
yeah, I've
Threadripper
seen
3, but
those. They're supposed
oh
to be pretty
man, come
awesome.
on.
Yeah.
So Can't get them yet. But the tests are just starting to come in. So I would do Threadripper 3 with NVIDIA GPU all day long.
Yeah, I don't think we have subsurface scattering for ray tracing yet.
No, but there was a new subsurface scattering that we just came out with in a Burley subsurface scattering. So much improved algorithm for subsurface scattering that just came out in 424. So just search Burley subsurface scattering, and you'll see, hopefully in the release notes or something, there's some before and after images, even
Cool.
though it's still in preview.
All right. Well, I think that's going to do it for us today. Again, thank you all so much for being here. We really appreciate it. And we'll definitely do more of these. And like we said already, the video will be up on the Unreal YouTube channel eventually this week, probably sometime. So thank you all, and we'll see you next time.
Cheers, everyone.